All right, so your class is right here, E, that's right. And the last time I'll review this will be the last time I do it. This is some vocabulary words, and we found out that chemical equations represent chemical reactions. That's good. Reactants are things that are going to react. They're on the left side. Products are things that are going to be produced. They're on the right side. The arrow means, hey, on the left side of the arrow, nothing's happened yet. On the right-hand side, oh, yeah, it's happened. So you got arrow means yields, produces, forms, will become, that. We have these little tiny symbols that help us out a little bit. We talked about yesterday, what's the difference between a liquid and aqueous? If I had liquid water, that's liquid. But what if I had NaClAq? That's sodium chloride dissolved in water. See that? That's different. They both look like water. But only one of them's really water. All right, the next thing was we find out that sometimes you have things like conditions that must be met. Like what if I said in a decomposition reaction you had to heat it? How would I represent that you had to heat it? I can't put it on the left because it's not a reactant. I can't put the word heat on the right because it's not a product unless it is produced. But I would put it on top of the arrow, wouldn't I? So you can actually put things on top of the arrow that you'll find out later. One of the experiments you'll be doing has to do with a catalyst. A catalyst is a chemical that speeds up a chemical reaction. It itself, though, is not consumed. It's ready to do it again. And I would put the catalyst over here because it's not really a reactant and it's not really a product. Okay. And then we have these things called driving forces. You'll learn more about that. Notice I only gave you 3. I have to wait till another chapter. And there's another chapter, and it's going to be talking about one of the biggest driving forces is a thing called the transfer of electrons. I'm not going to teach that to you right now, but transfer of electrons is somebody's going to gain electrons and somebody's going to lose. And we'll be talking about that in a separate chapter. Okay, so now I've been over here, and we found out that there were, for first year chemistry, I'm really only going to teach 5 classifications of reactions, okay? And I think you got the first 4 down. It was the 5th one. That's the one you got to be careful about. That one you got to have at least carbon and hydrogen in one of the reactants. You have to burn it. That means you got to combine it with oxygen, and then you have to produce carbon dioxide and water. And if you do, we're going to call you a combustion reaction. Now I can burn a piece of metal, but I'm not going to get CO2 and H2O, so it's not combustion. So here's one of those geometry things. Are all combustions, is all burning combustion? No. But is all combustion burning? Yes. So I can burn something and it not be combustion. But if you were to burn something and had this kind of a reactant and this kind of product, then we call it a combustion. All right, now I think your class also, did you guys also didn't you learn some little tricks? Let's see if you can remember some of the tricks here. And this is all review so far. The first thing I noticed is on this one, as I scan it, I noticed that there's an O2 here, but an O3 here, and that's called an odd-even mismatch. And so what I told myself is the smallest number they both go into evenly is 6, so I'll put a 2 coefficient here, that makes 6, and put a 3 here. Please make sure that you understand you're not allowed to change subscripts to balance an equation, are you? You have to make sure you write all the formulas correctly. And if they're all written correctly, then you balance it. You get that? And you only balance it with coefficients. Okay, so I put a coefficient here of 2, and here's 3. But be careful. That made you change the number of irons to 4, and you put that there. And one more time, even though this is trial and error, you always look back. And what if you'd had 8, 6, 4? What if you'd had 8, 6, 4? It would have balanced. But what are you required to do? If it has 8, 6, 4, what are you required to do? Reduce them. Got that? So every one of them has to be evenly divided to reduce it. Another thing, I'm not trying to be mean, but another thing you're required to do is, what if you go through here and it's already balanced with the ones? What if it's already balanced and you're required to write the word balance? I made a mistake. I don't know who I called on. Maybe it was me. But I think number 8 somebody told me, or I don't know, they said it was balanced. That was a mistake. So let's say clue number one, trick number one's odd even mismatch, okay? Let's do number two. Trick number two. Let's go down to number 9. If a polyatomic ion, like sulfate, if it stays as sulfate and doesn't break down into something like just sulfur, then you can actually balance it as if it was a single atom. So I see 1 sulfate here, but I see 3 sulfates here, so that's why I put a 3 here. So trick number 2 is if a polyatomic ion stays a polyatomic ion, you might even consider balancing that first. That usually helps you. Trick number 3, and this is where I don't know how I made a mistake there, but if you have a hydroxide on one side of the arrow and you have water on the other, if you write the water as HOH, watch what happens here. How do you classify that? Na plus HOH yields NaOH plus 8. How do you classify that? Isn't this sodium going to do what? Isn't the sodium kicking out the hydrogen? Is that what's happening? What do you call it? How do we get? How are you going to classify that one? Sodium kicks out hydrogen and forms a compound with OH. What do you call it when one element kicks out another element? How do you classify it?
Is it a single replacement?
What is it? Yeah, everybody got that? So by trick number 3, if you have hydroxide on one side, water on the other, if you write this as HOH, it was easy to classify. Now watch how it's easy to balance. 1 Na and 1 Na. 1 OH, see that? 1 OH. Looks like I'm in good shape. Uh-oh. 2 hydrogens that are not in hydroxide. 2 hydrogens that are not in hydroxide. How many have here? I only had 1, so I got to put a 2 there, don't I? So we need to put a 2 there, and that gives me 2 hydrogens that are not in hydroxide. 2 hydrogens. Okay, and then how many hydroxides does that give me? 2 hydroxides. Uh-oh, only 1. Now I have 2. 2 hydroxides, 2 sodiums, 2 sodiums. Now be careful, you might think you can reduce, but you can't, because guess what? If you have a coefficient of 1, you're done. I made it right. So if one of your coefficients is 1, you're done. You can't reduce that if one of them is 1, okay? All right, what do you think? Okay, let's go to this side. Did we balance any of these? All right, I'd like you to just on your own, I'll walk around, and on your own, I want you to try to balance it and see if you can catch maybe what some of the tricks are. So I'm just going to walk around, and if you're doing well, I'll just walk right by you and try to balance these. And by the way, the more you practice this, you just get better and better. You'll be slow at the beginning, and then you'll get better and better and better at this. I'm just going around. You said, hey, I'm having some trouble. Raise your hand. Stop. Oh, I forgot to review trick number 4 or 5. Do you remember the combustion trick? Okay. Let me do one more, okay? I'm sorry. Let me review one more thing, and then I'll leave you alone. Let you work on this. Back over here, back on here. There are combustion reactions like this one. See, that's not the wrong one. There are combustion reactions here, and I need to show you something. I think I let you have a couple minutes, and most of you could not balance this, right? And here's what happens. We have a combustion reaction. Some of them are incredibly easy. But what you want to do here is, I'll show you a trick. If you have a combustion reaction and see that 18 hydrogens, you want to put a 9 here because 9 times 2 is 18. If you put an odd number in front of a water on a combustion reaction, it will never balance, never. So what do? You double the odd number and make it, in this case, 18, right? So if you think you were supposed to put a 7 here, don't do that, just double it. Okay, that's my last review. And I said, some combustions are easy, some are hard. Yes.
I do three.
Okay, let's take a look at it. What I would do is, if you write these as HOH, see that when you have hydroxide, write the HOH and let's see what happens. Wow, now, I used to have that trouble too. But now, look over here, I have two hydrogens that are not in hydroxide, but I only have one here. So I'm gonna put two in front of that.
So that's separate from me.
Yeah, so that's two H's, and now it's also, yeah, these are H's that are not in hydroxide. So I have two hydrogens not in hydroxide, but I also have two hydroxides. How many hydroxides here? So now you have two, that's good. Put two there, that's good. Now you have two hydroxides, two hydroxides. How many sodiums do you have? You have two there. How many sulfates do you have? One. You got it. And then check to see if it can be reduced. Question? Question? Again, the more you try these little tricks, the better you get at this, right? If you're having trouble with number 3, one of the tricks was, I see hydroxide on one side and water on the other. If you write the water as HOH, I think you'll find it be easier. Okay, so that right now, that would be 2 times 18, 36 hydrogens. So I have to put a 2 here to get 36 hydrogens. How many carbons is that? That's right.
Wait, what's that?
16 times 1. That's C1O2. So now you put how many carbons? What's 16 times 2? Right now 32. What's 18 times 1? Add those together. I have to have 50 oxygen over here. What's that one? Okay, we have A plus B. No, A plus B yields AB. Same service. That's right. Good question. I like this. I like this walking around. Notice that there are two hydrogens here that are not in hydroxide. Now, how many hydrogens are not in hydroxide over here? One, two. So that gives me two H's, and it also gives me two OHs. I have two hydroxides, and I only have one hydroxide here. Nice. That gives you two sodiums. Two sodiums. How many sulfates? We always check to see if we can reduce. They have a 1 that we take out. Good. Good. Looking good. I'm not sure if this is the page. There's one page where there's one that's really hard. Is this one of them? Was there one of them that's really hard? Okay. Let's see if we can get 7, all right? 7 is just, can you grunt it out and can you not give up, okay? Maybe you didn't even have any tricks here. You just gotta stay with it. But we're gonna see if anybody gets that. Check, double check. It's kind of a little puzzle. Some of you are gonna get really, really good at balancing, but it takes practice. See, I already know that number 7 is gonna be hard, because guess what happened to my nitrates? Oh, they didn't stay as nitrates. That's always a bad sign when you have to balance something. The polyatomic ion breaks down, and then you have, sometimes you have trouble balancing. How are we getting down here? How far are you down? Okay, you got them all except 7? Okay. We'll see who can come up with 7. All right, we'll see what happens. All right. Okay, let's start, and I'm just calling some people, and you might have gotten it, you might not have gotten it. You say I'm stuck or whatever. Let's go with how about Ty? Ready? How about number one? What do you see there? How did you do this one?
Well, I like first want to get the oxygen balanced, and so I did 3O2, and then
Okay, and so you saw an odd even mismatch.
yes,
Okay, so what did you put here?
3O2, and then 2.
Okay, so then what? Are you done?
No, and then I balanced the aluminum, so I did 4Al.
And then did you make sure it couldn't be reduced? Okay, what do you think? Everybody get that right? All right, Elizabeth, how about the second one?
I put 2,
Where, here?
2 mercuries. And then 2 mercuries on the other side.
So you saw 2 O's here, so you had to have 2 O's. Then you had 2 mercuries, 2, can you reduce it?
No.
All right, because there's a 1 here, isn't there? Very good. All right, Caroline, Fox. How do you do this one? Say it a little bit louder.
I put 2, like HOH, like the.
Did you change water? So if you see hydroxide on one side and water on the other, okay, we got that. Now how do you start this thing?
I did 2 of those.
One more time.
I did 2 of those.
2 of what? When you say those, see how many those there are? Huh?
4.
Why? Why would you want 2 waters?
Because you had 2 hydrogens.
See over here, yeah, I had 2 hydrogens that were not in hydroxide, but here you only have 1. So you put a 2 here, right? That gives you 2 hydrogens that are not in hydroxide. That's good. But doesn't that give you 2 hydroxides? What are you going to do about that? You have 2 hydroxides.
So then if you put 2 on both.
Is that right? Are you done? But that gives you 2 sodiums. You didn't check that, did you? You have 2 sodiums. You have 2 sodiums over here? And what about sulfates? You check that? How many? How many sulfates are here? Don't say 4. 1. And how many sulfates here? 1. Everybody got it? All right. Ethan, you want to do the next one?
Sure. So the oxygens, there's an odd even.
Yes.
So I did 3 oxygens, and then I put a 2,
Okay.
and then that means that there needs to be 4 ions, so I put a 4.
And can it be reduced?
No.
Okay, good. We got it. Next one. Tyler.
I'll put a 2 on this one.
Say it again.
I'll put a 2 on
Wait, tell me the name. Where do you want to put it to?
in front of the lead at the start.
Lead chromate or lead nitrate?
Lead nitrate.
Why would you put a 2 there?
I don't know.
As I scan through here, I noticed that nitrate stayed as nitrate, right? How many nitrates are on the left? 2. How many on the right? So don't you have to fix that, right? So how many potassiums does that give you? How about over here? Okay. Let's check lead. 1 lead. 1 lead. How many chromates? How about here? What do you think? Can it be reduced? All right, there you go. That's that one. 6. Davis. One more time. Yes.
So I put a 2 on the right side, then I put a 3 in front of the hydrogen on the left side.
Okay, over here. 3. That gives you 6 hydrogens and 6 hydrogens. That works. What about nitrogen?
Well, there's already 2 on the left, so.
Yeah.
I'll do
That's it. Very good. All right, did anybody happen to get number 7? You think you did? All right, tell me how you did this. Because I know it's going to be hard because I can see the nitrates all messed up. And what do you have?
So I have.
What do you have in front of this guy? 4? All right, we're going to try it. What do you have in front of CO2?
12.
Ooh, 12. How about in front of nitrogen?
6.
6? Man. How about the water?
10.
10? Man. And what about the O2?
4.
Ooh. Let's see if it works. Ready? Let me show you how to check this. First of all, I have 4 times 3 carbons. How many is that? That's 12. Let's go over here. 12 times 1 carbon. That's 12. Okay. Looking good so far. 4 times 5 hydrogens. 20. 10 times, there's 20. 20 hydrogens. 20 hydrogens. Okay, now, here's the tricky part. Watch. How many nitrogens? 4 times 3 times 1. Everybody see what I did there? 4 times 3 times 1. That's 12. 12 nitrogens. Ooh, you're looking good so far. You only have one more. If one more works, let's try it. How many oxygens? 4 times 3 times 3. Woo! How many is that? What's 4 times 3 times 3? 36? 36 oxygens. Let's see if we got it. No, you only have 2 here. Oh, wait. You had 2 times 12. You had 24 oxygens. Then you had 10 more. That's 34, 35, 36. Ding, 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 ding. That's very good. That's very, very good. Did anybody else happen to get that one right? That's a tough one. You were close, right? I bet you were 1 oxygen away, weren't you?
I said that the oxygens were equal to 27 instead of 36.
Oh, okay.
Basic math.
Anyway, this one, I didn't have any tricks for it. It just gutted out. You have to gut it out and don't give up. So give you a lot of credit for that. That's hard to do. Let's do the next one. 8. Max.
I said it was balanced.
1 iron. Oh, so you're required to write the word balance then? Do you know that every year, I'm not trying to make fun of anybody. Every year, I give a test on this, okay? And I have about 12 of them you have to balance. And if it's balanced, you have to write balance. Some people misunderstand what I'm saying. I saw somebody do this. They wrote all the coefficients and then they get balanced. Yeah, wait. When I say write balance, what does that mean? It doesn't mean you balance it. It means what? When you write this, what does it mean? It's already balanced. You didn't have to do anything. Get that? But every year I have somebody who'll go balance, 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 because they balance them. That's not what it means. Okay? All right, good. All right, here we go. Who have I called on for a while? Danielle. You're doing this one.
I put a 2 at the beginning
Why?
because
Ooh, miss.
I guess I won't start there. So I put a 3 in front of the oxygen.
Okay. Why?
And because you have a mismatch. And so
Odd, even. Yes. What are you gonna put here?
you have to put a 2 at the beginning.
Okay.
And because of that, you have to put a 2 in front of the potassium.
We have 2 potassiums here, only 1 here. But wait, that gives you 2 chlorines.
You have 2 chlorines.
All right. What do you think? I gotta look at your faces, right? And by the way, if you don't quite catch on today, the more you do these, the more you do, just get better and better. All right, last one. Madeline, you wanna do that for me?
I put a 2 in front of the hydrochloric acid.
Because you saw 2 here, 2 H's here, right? That gives you 2 chlorines, though. How many? You got 2 chlorines on the left. How many on the right? You have 2 chlorines on the left. How many on the right?
2.
That's good. That's balanced, right? But you have 1 magnesium here. How many over here? So that's it. Everybody got it? What do you think? Getting better at this? All right. Let's do a few more. How about that? Over here on this side, which side? This side. Okay. This one just says to identify them, and this one says to balance them, okay? Let's do these. I like these. I like them better. All right. Let's go ahead and try. I'm going to try, since they didn't have any combustions on the other one, let's try some combustions, okay? And there we go. So you can try those three first, and then after you do those three, you can go after any ones you want, all right? And again, I'll walk around just a little bit, and some combustions are easy, some are not. But in every case, do not put an odd number in front of the water on a combustion reaction. You guys are picking up on this pretty fast. If you need to rewrite the equation, that's why they gave it a big blank there. If you need to rewrite it, there's a little more space. Did they get all three combustions right yet? On combustion, put an odd number in front of that water, it won't work. You'll have to double that odd number, and then you'll be okay. Don't get discouraged also. Combustion reactions are, if you're going to get some big numbers, they're probably going to be combustion. The one that Noah just did, that's some of the biggest numbers I've seen that were not combustion. Most of the time, 6 might be the biggest number I usually see, except for combustion. Okay, let's stop. And who have not called on? I think, okay, let's do, Kayla. What about number 7, Kayla? What do you think? You like these? All right, combustion could be the ones. Can I help? I'm gonna help you a little bit here. Let's scan through here, and it is combustion, right? You have a carbon hydrogen fuel, and you get burning it, and you get carbon dioxide. So it is combustion. Now again, I would not write this as HOH. The only time I told you to write HOH is when you had hydroxide on one side, water on the other. So as I go through here, here's another clue I have for you. do you notice how many things have oxygen in them? Well, I don't need to start with oxygen because there's too many things that have oxygen, so I can either start with carbon or hydrogen. Here's one carbon, here's one carbon, and Kayla, how many hydrogens on the left? Two? How many? How many hydrogens on the left?
On the left,
4, and how many here? So how are you going to fix that?
I put it 6 in front of this new.
Did you put a 2 in front of the water?
No,
If you did, that would give me how many hydrogens?
4.
That would get, and that's what I want, isn't it? Now, that's also good because putting an even number in front of the water is good. Good. You get it? Now, Kaylee, help me out here. I'm going to add up how many hydrogens are on the right side of the arrow. How many, Kayla, how many hydrogens, I'm sorry, how many oxygens are on this thing?
2.
2. And how many oxygens are on this?
1.
It would have been 1, except that coefficient distributes. So look this. It's 2 times this, but it's also 2 times 1. So there's actually 2 oxygens here and 2 here. So how many total? 4 oxygens, and how many here? There's 4? There's only 2, but I can make it 4, can't I? So now watch. 4 oxygens, 2 plus 2 more, 4 oxygens, 1 carbon, 4 hydrogens, and that was a combustion. It wasn't so bad. That wasn't too bad, was it? All right, let's go with Jonathan. How about the next combustion? Okay, so you saw 8 hydrogens here, and putting an even number in front of the well, that's good. That's good. Okay, so you have 8 hydrogens. What about carbon? Okay, I like that. How many oxygens are right here, just in this part? 6, and how many over here? 6 and 4 is 10. Yeah, nice. What do you think? All right, Davis, you're gonna do the last one. What do you got here? What do you want to start with? Don't start with oxygen. It's in too many things.
I started with the hydrogen,
Okay.
so it would be 9, but not,
You said, I'm not doing that.
yeah, so I doubled it, put 18.
Nice.
And then you have to put a 2.
Wait a minute. You know how many that gives you, though? Man, that gives you 36 hydrogens. How are you going to get 36 hydrogens over here? Okay. So that gives me 36 hydrogens, but how many carbons does that give you? Okay. Woo. Okay, now, how many oxygens are just right here, just here?
32.
And how many are just right here? 18 times 1? How many is that total? Okay, something times 2 has to equal 50. Now, can it be reduced? No. Okay, good job. What do you think? Everybody got that one? That's the same one that was on the other page, by the way, but that's all right. All right, now, I would say, I'm not giving you any homework, but if you could practice these, if you had any time to practice these, I do want to do one more thing before the end of the day. I'd like to show you the pinnacle of balancing equations. If you don't catch on to the pinnacle today, just forget about it till we come back. You get that? But what I'd like to do is, I'd like you to sit, you can move a little bit closer to somebody, and why don't we have that whole row, talk to each other and try to do number 1, and then this whole row is going to talk to each other, try to do number 2. You're going to do number 3, and you guys are going to do number 4. And if you want to go back to a table, if you want to find a table and sit together, you can do that. But this is going to be a challenge, and it's okay if you don't get these right. This is going to be your biggest challenge. I'm going to walk around and help you out. they're going to be working on changing words into Khmeres, I call it, and this will be the biggest struggle. And then once they conquer this, they'll know how to do it really well. I'm going to stop the video now.